Stock is a data structure used to store a collection of data. Objects can be retrieved using a pop operations, which remove an item from the stack.
When an object is added to the stock, it is placed on the top of all previously entered items.
When an item is removed from the stack, it's either the top or the bottom.
A stock in which items are removed are considered as LIFO or last in, first out stock.
Application of stacks. Stack is used to evaluate prefix, postfix, and infix expressions. A stack is a recursive data structure. So what is recursive? Recursive or recursion is a programming pattern that is useful in situations when a task can be naturally split into several tasks of the same kind but simpler.
Stack is recursive. A recursive function is a function that calls itself until a base condition is true and execution stops. While false, we will keep placing execution context on the top of the stack. This may happen until we have a stack overflow. A stack overflow is when we run out memory to hold items on the stack.
There is two representation of stacks. One is one-dimensional array and the two is as a singly linked list. There are three operations of stacks. One is push, that adds item at the top of the list. Pop, remove item from the top of the list. And pick, access value at the top of the list. Expression trees using stacks. An expression tree is a binary tree in which the root nodes are operators and the leaves are the operands.
What are the real-life applications of stock data structure? Number 1. Browser backport button. Second, pile of plates. Third is piling of chairs. Fourth is a stack of book on table.
Of expression using stacks. An expression is made up of expressions and operands. Operations to be performed on the operands are described by the associated operators. Operators of a higher precedence are processed first. Evaluation is performed from left to right.
In INFIX notation, there is an operand, operator, and operand. While in POSTFIX notation, there is operand, and operator.
What is the higher operator between these four? First is, this is the higher, multiplication and division. The second one is the subtraction and the addition. Do you want to learn how to convert INFIX to POSTFIX?
Algorithm for converting INFIX to POSTFIX. Number 1. Read the symbols one at one. Number 2. If the symbol is an operand, push it into the stack or POSTFIX stack. Number 3. If the symbol is an operator, check the topmost of the stack. Operator stack. If the topmost has higher precedence or equal than that of the symbol, pop the topmost. Then push the symbol you are reading into the stack. Here is the example. This is the INFIX. We must read A. Since A is an operand, we must write it on the POSTFIX. Next, it is an operator. We must write it on the stack. Next, B. Since B is an operand, we must write it on the POSTFIX. Next, it is the sign of addition and it is an operator. Since the first rule is if the topmost has the higher precedence or equal than that the symbol, pop the topmost, then push the symbol that you are reading. And the one that you will pop, you will write it on the postfix. Next is letter C. Since C is an operand, we will write it on the postfix. Since we're done reading the infix notation, the remaining on the stack should pop starting from the topmost. Then that's it. The operator or the topmost has a lower precedence. Here is the example. Again, this is the infix notation. Since A is an operand, we must write it on the postfix. Next, additions. Since addition is an operator, we must write it on the stack. Next is letter B. Letter B is an operand, so we must write it on the postfix. Next, operator. The operator is multiplication. And the topmost is addition. If the topmost has a lower precedence than that of the symbol, push the symbol you are reading into the stack. Next is letter C. Since letter C is an operand, we must write it on the postfix. Now, we're done reading the infix notation. And the remaining on the stack should pop starting at the topmost. Then, that's it. Here is the example. This is the infix notation. The first one is an open parenthesis. We must push it on the stack because parenthesis is the most powerful and higher precedence. Now, the second one is letter A, which is an operand. So we must write it on the postfix notation. Next is addition. It is an operator. We must write it on the stack. Next one is letter B. Letter B is an operand. We must write it on the postfix notation. Now, the next is close parenthesis. If we encounter the close parenthesis, pop all symbols between the open and close parenthesis. Since the symbol between the open parenthesis and close parenthesis are addition, we must pop it and write it on the postfix notation. Next, it is an operator, so we must write it on the stack. Next is letter C. Since letter C is an operand, we must write it on the postfix notation. Now, we are done reading the infix notation. And the remaining on the stack should pop starting from the topmost.
To create the expression tree, we should convert the infix notation to postfix notation.
This is the infix notation. We must convert it into postfix notation to create the expression tree. Number 1 is the open parenthesis. We must write it on the stack. Then open parenthesis again. A is an operand. We must write it on the postfix notation. Then multiplication is an operator. We must write it on the stack. B is an operand. We must write it on the postfix notation. Next, again, if the topmost has higher precedence or equal than that of the symbol, pop the topmost, then push what are you reading symbol or what symbol are you. Next is letter C. It is an operand. We must write it on the post. Next is the close parenthesis. Again, if we encounter the close parenthesis, pop all symbols between the open and close parenthesis and write it on the postfix notation. Next, it is an operator. The letter D is an operand. We must write it on the postfix notation. Next is the division or operator, and as what we've said, if the topmost has a lower precedence than the of the symbol, push the symbol you are reading in the stack. Next is letter E. It is an operand. Next is multiplication. Again, if it's higher or equal to, then pop the topmost. This is the topmost. Then push symbol. What are you? Next is an open parenthesis. F is an operand. You must write it on the postfix. Next is an operator. You must write it on the stock. Next is an operand. Write it on the postfix notation. Next is close parenthesis. Again, if you encounter the close parenthesis, the operator between the close parenthesis and open parenthesis should be popped. Put it on the postfix notation. Next is close parenthesis. Since the last is the close parenthesis, all the operator or symbol between the open and close parenthesis should be popped. First is multiplication, and last is addition. Then that's it. Since we have the postfix notation, we can do the expression 3. Here is the rule. Read one symbol at a time. If the symbol is an operand, create a node 3 and push it into the stack. If the symbol is an operator, pop the two topmost element from the stack, create a 3 and push the symbol into the stack. A is an operand. If symbol is an operand, create a 1 node 3 and push it into a stack. B is also an operand. And the symbol is operator. If the symbol is operator, pop the two topmost element from the stack, create a 3 and push the symbol into the stack. Next is an operand. Next is an operator. Since the symbol is an operator, pop the two topmost element from the stack, create a 3 and push the symbol into the stack. Next is an operand. Operand again. And then operator. Pop the two topmost. Next is an operand. Then operand again. An operator. And operator. Pop the two topmost and create. And the next is an operator again. Pop the two topmost. And the last symbol is an operator. Pop the two topmost.